Hey, welcome back for example 3 in our notes for polynomial long division. And in example 2, we were dividing using linear divisors. In example 3, we're going to move on to quadratic divisors. And the process still looks very much the same, where we're going to write our dividend from the numerator by putting zeros in for any missing place values. And the only thing that's a little different is if your denominator, your quadratic denominator, which is your divisor, is not in standard form, you're going to put it in standard form before you try to do the long division. So in example B, notice we have two linear factors in the denominator. You would FOIL to get those together into a single quadratic expression in standard form and use that as your divisor. So let's start with example A. We're dividing x squared minus 4, which is going to need a 0 for the linear place value since that's missing. So that's a 0x. And then minus 4. We're going to divide that into the dividend 3x cubed plus x squared plus x minus 1. And then we're going to ask ourselves, what do we multiply times x squared to get 3x cubed? And that would be a 3x. And then we'll multiply 3x times x squared is 3x cubed. Then 3x times 0x is a positive 0x squared, and 3x times negative 4 is a negative 12x. And then we're going to draw a line and change all three signs now because there's three terms. So minus, minus, positive. And when we simplify 3x cubed minus 3x cubed, that's 0. That cancels. X squared minus 0x squared is x squared. Then positive x plus 12x would be a positive 13x. And then we're going to bring down the constant here at the end, which is negative 1. Okay, then we repeat that algorithm and ask ourselves, what do we multiply times x squared to get x squared? And that would be a plus 1 in the quotient. Then we distribute, so 1 times x squared is x squared. 1 times 0x is positive 0x. 1 times negative 4 is negative 4. And then we're going to draw a line and change all three signs. So negative, negative, positive, and combine like terms. So x squared minus x squared cancels. That's a 0. 13x minus 0x is 13x. And then negative 1 plus 4 is a positive 3, and there's no more terms for me to bring down, so that would be my remainder. This binomial that I see here at the end is the remainder to that. And since the remainder is not 0, I know that this x squared minus 4 is not a factor of the polynomial 3x cubed plus x squared plus x minus 1. Okay, so notice here in step number 3, it reminds me if the remainder is 0, the polynomial can be written as a product of factors. The remainder is not 0, so the factor theorem does not apply here, and instead I can only represent the quotient, which would be my solution. So that quotient is 3x plus 1 plus, and then my remainder, which is 3x plus 3, over the divisor, which is x squared minus 4, right? And that is how I would represent the quotient to that division problem. Remembering that it is not a factor, right? X squared minus 4 is not a factor because my remainder wasn't 0. Okay, so when we try example B, I'm going to have a dividend of x cubed plus x squared minus 5x plus 3. And then my divisor, remember up here it said write your divisor in standard form, right, and put in any zeros for missing place values. So I'm going to FOIL this out. That's a perfect square trinomial. So when I FOIL, I'm going to end up with an x squared minus 2x plus 1. Okay, that's the perfect square trinomial shortcut. So when I go to do this division, how many times does x squared go into x cubed? It goes in x times. So multiply x times x squared is x cubed. X times negative 2x is a negative 2x squared. X times positive 1 is a positive x. And then I will draw my line and change all three signs. Combine like terms, and I have x cubed minus x cubed. That cancels as 0. X squared plus 2x squared is a 3x squared. Negative 5x minus another x is negative 6x. And then I can bring down my last term, the constant 3. Then we repeat that algorithm. So how many times does x squared go into 3x squared? That would be positive 3 times. And then I distribute. 3 times x squared is a 3x squared. 3 times negative 2x is a negative 6x. 3 times positive 1 is positive 3. Then we draw a line and change all three signs. And when we combine like terms, all three of these cancel and leave a remainder of 0. So remember up here, step 3, if the remainder is 0, then the factor theorem applies, and I can write this x cubed plus x squared minus 5x plus 3 as a product of factors, where the factors are the divisor, so x squared minus 2x plus 1, that's my divisor, and my quotient, x plus 3. And I already know how to factor the divisor because it was given to me originally in factored form, an x minus 1 times another x minus 1. So to completely factor this, I would represent this trinomial as x minus 1 quantity squared, and then my linear factor of x plus 3. And that would be a bounce at positive 1 and a cross at negative 3. The end behavior would be starting down on the left and ending up on the right because it's an odd degree and a positive leading coefficient. So we'd be able to sketch that graph really quickly, knowing that the remainder was 0 and that completely factored. Okay, so some scratch paper or on your dry erase board, go ahead and try this problem on your own, and then when you're ready to go over it together, you can resume the video. Okay, so here is the solution. I took the divisor, x squared minus 1, and I divided it into x to the 4th minus 5x squared plus 4. I put the zeros in for the missing place values here in my dividend, but I did not remember to put them in to my divisor. And I did that deliberately just to show you that it's not the end of the world if you forget to put the zeros in for missing place values, so long as you space things out according to where those place values should be. So for example, when I ask myself x squared times what goes into x to the 4th, the answer is x squared. I record that in my x squared place value column here, and then when I distribute, x squared times x squared is x to the 4th. X squared times 1, though, is x squared, so I write it in the x squared column, right? Had I put a 0x in here for that missing place value, then I'd have x to the 4th plus 0x cubed plus x squared. So I just wanted to show you that if you're careful about place value, you can get away without putting those the missing zeros in. Okay, when I end up with my remainder of 0, Then I have my divisor as a factor, x squared minus 1. The quotient is also a factor, x squared minus 4. Those are both a difference of squares. So my x squared minus 1 factors as x plus 1x minus 1. X squared minus 4 factors as x plus 2x minus 2. And that would be 4 crosses at x equals -1, 1, -2, and 2. It's an even degree and a positive leading coefficient, so both ends point up.